In 1941, a wounded Soviet sergeant lies in a military hospital. In the beds around him, other soldiers speak quietly. They speak about their rifles, about weapons that fail in mud, about mechanisms that freeze in winter, about tools that demand precision in places where precision is impossible. The complaints are not political, they are practical. He listens carefully, not with anger, not with ambition, with curiosity. If a weapon must survive the same conditions as the soldier who carries it, why does it depend on delicacy? The question stays with him long after the conversations fade. Mikhail Kalashnikov was born in 1919 in rural Siberia. He grew up in a farming family that was later displaced during Soviet collectivization. His early life was shaped by hardship, mechanical curiosity, and a state that valued industrial function over individual identity. He was not raised in an engineering academy. He was raised in a landscape defined by labor. As a teenager, he developed an interest in machinery, small engines, tools, systems that moved because each part depended on the other. When Germany invaded the Soviet Union in 1941, Kalashnikov was serving as a tank commander in the Red Army. He was young. He had no formal design authority, but he was inside a system that demanded resilience above all else. During combat, his tank was hit. He was wounded and evacuated. In recovery, he began sketching ideas, not from a position of power, not from ideology, but from observation. He had seen equipment fail under stress. He had seen how fragile systems collapse when exposed to uncontrolled conditions. The war was not an abstract concept to him. It was mud, it was cold, it was exhaustion. And somewhere between injury and recovery, a question began to form. Not how to build something more advanced, but how to build something that would continue to function when everything else breaks. This was not yet a global story. It was a practical one, a soldier thinking about durability.
After his recovery, Kalashnikov did not immediately create a final weapon. He began experimenting. His first prototypes were not adopted. They were tested, rejected, reworked. The Soviet military establishment was not interested in sentiment. It evaluated performance. During the late 1940s, the Red Army analyzed battlefield data from the war. Combat distances had decreased. Mobility mattered more than long-range precision. Automatic fire had proven decisive in close engagements. The Soviet command sought a standard infantry weapon that could replace multiple existing systems. It needed to be reliable, it needed to be simple, it needed to function in mud, sand, snow, and neglect. Kalashnikov entered formal design trials. Competing engineers presented their own models. Prototypes were fired, stressed, disassembled, evaluated. Kalashnikov's approach emphasized mechanical tolerance. Loose internal clearances allowed the mechanism to cycle even when contaminated. The design sacrificed refinement for resilience. In 1947, his improved model passed state trials. It was adopted and designated the Automat Kalashnikov, the AK-47. But at the moment of adoption, it was not yet a symbol. It was a standardized solution, a design aligned with doctrine, a weapon built not for ideal conditions, but for failure. The weapon did not remain a prototype for long. In a nation recovering from war and preparing for future uncertainty, experimentation was only a temporary stage. A prototype could validate an idea, but an army required something repeatable. Factories began preparing for scaled production. Blueprints moved from design tables to industrial planning offices. Supply chains were calculated. Steel allocations were adjusted. Machinery was reorganized to accommodate output, not refinement. The question was no longer whether the rifle worked. The question was how many could be produced and how quickly. The design was adapted for manufacturing efficiency, not to improve it under ideal laboratory conditions, but to ensure that it could be built consistently in imperfect factories. Tolerance became a strength rather than a weakness. Simplicity became a requirement, not a compromise. Stamped components replaced more complex machining where possible. Processes that once required time and precision were simplified into repeatable mechanical actions. Parts became fewer. Each reduction removed friction from the system. The goal was not refinement. Polished surfaces did not define military value. Mechanical elegance was secondary. The goal was volume, because in modern warfare, scale becomes strategy. One rifle is equipment. Hundreds of thousands become infrastructure. The Soviet Union required standardization across vast territory. A weapon produced in one region needed to function identically in another. Distance demanded uniformity. Variation introduced uncertainty. Production lines were optimized. Assembly steps were simplified. Time per unit was reduced. Workers were trained, not as individual craftsmen shaping unique pieces, but as operators within a synchronized industrial rhythm. The system expanded beyond a single factory. Replication became policy. Industrial capacity multiplied outward. What had begun as an engineer's solution became an industrial process, and once embedded into infrastructure, the rifle no longer depended on its creator. It depended on the system that sustained it. And systems, unlike individuals, are built to scale. As the Cold War intensified, the rifle moved beyond Soviet borders. It did not travel as a commercial product. It moved as part of alliances, as part of doctrine, as part of strategic influence. Licensing agreements allowed allied states to manufacture their own versions, not identical in name, but identical in function. Factories in Eastern Europe began replicating the system under state coordination. The design crossed languages without translation. Factories across Eastern Europe began production. Industrial centers in Poland, Bulgaria, Romania, and East Germany integrated the platform into their own military infrastructure. Standardization extended beyond one nation. Then Asia. Production lines emerged in China and North Korea. The rifle adapted to new political environments without altering its mechanical identity. Then parts of Africa. Where industrial capacity was limited, the design required little modification. It functioned in climates and terrains far removed from its origin. The rifle did not spread through advertising. There were no campaigns, no branding. It spread through geopolitics. Military aid programs included it. Crates of rifles accompanied shipments of equipment and advisors. Armed forces adopted it as a baseline standard. Revolutionary movements adopted it, not because it was symbolic, but because it was accessible. It required minimal training, minimal maintenance, minimal infrastructure. Governments standardized around it. The rifle became embedded in defense doctrines across continents. Uniformity simplified supply chains. Shared parts reduced complexity. Its simplicity made training easier. Recruits could become functional operators in days rather than months. Its durability made logistics predictable. Harsh environments did not demand constant repair. Its cost made scale possible, and scale, in the context of the Cold War, translated into leverage. By the 1970s and 1980s, the rifle was no longer confined to a single ideological bloc. It had become a constant presence in conflicts that differed in cause but shared a common tool. What began as national standardization evolved into global saturation. Over time, the rifle became more than equipment. It became recognizable, not by name, not by technical specification, but by outline. Its silhouette appeared in photographs, on flags, on propaganda posters, in news footage across continents, in black and white archives, in color broadcasts decades later. Different languages, different ideologies, the same shape. In some regions, it symbolized resistance. In others, authority. In many places, simply survival. It did not need translation. The curve of the magazine, the straight gas tube, the fixed wooden stock. Even at a distance, even partially obscured, even carried at rest,
The form remained identifiable. Children growing up thousands of kilometers apart could recognize it without instruction, not because they studied it, but because they had seen it. On murals, on recruitment banners, on state insignia, on armbands, on monuments. The design required little explanation. Its geometry was uncomplicated, its proportions consistent, its outline resistant to alteration. Unlike complex systems that blur into machinery, this object retained a human-scale clarity. It did not disappear into abstraction. It remained a shape. As decades passed, the rifle detached from its origin. It was no longer associated with a single factory, a single engineer, or a single doctrine. It became portable across narratives. In regions of political instability, its presence suggested control. In regions of foreign occupation, it suggested defiance. Yet mechanically, it remained indifferent. Metal and wood, mass-produced, interchangeable. Its global presence was not driven by aesthetics, it was driven by repetition. Scale created familiarity. Familiarity created symbolism. Symbolism created permanence. The design did not adapt to culture. Culture adapted to the design. Over time, the rifle stopped being introduced. It was assumed. In news footage, no caption was necessary. In photographs, no label was required. Its form became universal.
The rifle did not remain a tool of states alone. It entered movements, not as equipment, but as identity. Across Africa, Asia, and Latin America, it appeared not just in the hands of fighters, but on banners and emblems. It stood for resistance, for anti-colonial struggle, for liberation. In some cases, it moved from battlefield to flag. One nation would engrave it permanently into its national identity. Mozambique placed its silhouette on its flag, an armed revolution becoming statehood. The rifle had crossed a threshold. It was no longer simply issued, it was represented. But symbolism carries weight. The same simplicity that allowed mass production also allowed uncontrolled spread. Cheap to manufacture, durable in extreme environments, easy to operate. In civil wars, in insurgencies, in collapsing states, it multiplied. The barrier to entry lowered, the scale of violence expanded. Children could carry it, militias could sustain it, conflicts could prolong themselves. What had been engineered for defense became embedded in cycles of instability. The rifle did not decide its context, but it shaped it. Decades passed. Technologies evolved. Optics improved, materials modernized, armies digitized. Yet the original platform remained. Modified, copied, reproduced across continents. Even in the 21st century, variants of the design persist, not because it is the most advanced, but because it is sufficient. In regions where maintenance is limited, where supply chains are fragile, simplicity outlives sophistication. The design endures not as innovation, but as infrastructure. Mikhail Kalashnikov would later say he designed the rifle to defend his homeland. History would take it further. What began as an answer to wartime necessity became the most distributed weapon in modern history. It is both engineering achievement and human paradox, a product of industry, a symbol of revolution, a participant in tragedy. Its silhouette is simple. Its legacy is not. History rarely remembers objects. It remembers what they shaped. Some tools disappear with time. Others outlive the moment that created them. This one did not fade. It remained, not because it changed the world alone, but because the world kept changing around it.